Hi, so for the past few weeks I was trying to make Mover work in Blueprints and I was partially successful, so let me show you what I have right now. So if I press play, I have the character and he can move around and things look okay, but there is some weird stuff that is happening, so I didn't make it 100% working. But as you can see, when I go to the slope, my character is tilted, which I don't think should happen. Also, if I try to fall, it's kind of weird, then he also gets pulled towards the direction for some reason. Also, the fall only starts at some point, I think when the whole capsule can go down for some reason. So there is like random bugs, but in general it is working. So let me show you how I did that. First, let's go to the agent pawn and just talk about generally how Mover works. So we have the character mover component, and in here you have your movement modes, and each movement mode executes on tick and basically calculates the position, rotation, everything related to the character movement. The whole idea is that you can have these movement modes that you can add or remove at runtime. They can be dynamic, you can create custom that are your own, and you can just basically plug them in, and if you made them correctly they should work. You also have stuff like transitions. How do you go from one mode to the other if you need like a smoother transition or the instant transition? You also have shared settings. All of your movement modes can share some general data like the walking speed, acceleration, stuff like that, and that's kind of the general idea of the mover. First, what I did is just create a new base movement mode, and for right now I only have a walking movement mode working in Blueprints, and falling and flying are in C++. So let me open up the walking movement mode. So in here we have two big functions that basically run most of the functionality for the movement mode, which is onGenerateMove, which basically tries to get your intended move, and then that is passed to the simulation tick, and simulation tick actually calculates stuff, tries to do offsets, do collision checks, stuff like that. So let's see how onGenerateMove works. So first let's go to agent pawn and just see the movement modes. So first we start with the falling movement mode, and then since the falling quickly switches to the walking movement mode, then we go to that mode and basically we start executing our code. And because in Blueprints, for some reason this onGenerateMove function is read-only, I was not able to do all of the functionality for figuring out what move we want to make here. So what I did is create an interface with just one function, which is walkGenerateMove, and on the agent pawn is actually where we do all of that functionality, actually do those calculations. And in here we just call it. So I think how they're doing it in C++ is because you can initialize variables in the read-only function. It is fine in C++ to do stuff, but in Blueprints, since you cannot do set in the read-only function, I basically can't do anything. So that's why I had to do this. So if you go to the agent pawn, let's go to the walkGenerateMove. So this is our functionality. We get the starting state. So basically what is the current state of our character, his velocity, orientation, stuff like that. Time step, so the actual tick, millisecond, stuff like that. So all of these you can also break, get some info about them. So the milliseconds for this step, and later we were going to use that to basically figure out if we move a little bit, then we have maybe remaining time and use that, stuff like that. But for now, what we're doing here is doing some line traces to check for the floor. We get some data about the normal over floor, the direction we want to move. One important thing is also this data from collection. So this is something that I was first introduced in this mover component. But if I understand correctly how it works, is basically you have this data, the collection of data, and it's like a container for structs that you can match and see if you can get some data out of the collection. So for example, let's say we have a container, and let's say we put in the container 3 types of structs. Then what we can do later is ask the container, hey, I want the struct of type default sync state. And then he's gonna try to find it here, and basically give us this struct. So basically that's what's happening here. So I'm taking this collection, and we are assuming there is some stuff in the collection. And so now in Blueprints, if I try to do this and then get data, you can see how we have the wildcard here, meaning we don't actually have anything. It can be multiple types. What we can do is pull. Usually what I do is, let's do break, default sync state. Let's do this one. And now it kind of collapses to this type, and then we can use it. So maybe I can right click, propose to variable, stuff like that. But yeah, that's basically how, in general, you use this collection. So basically what you're doing with the collection is you can add that data to the collection, and you can take the data out of the collection. And what we are doing here is we are taking data, which is default sync state. So what is our current sync state? And it's basically what we talked about before, which is location, orientation, velocity, stuff like that. And then we are just calculating stuff. Here is a friction. And after that, we do some calculations to just figure stuff out. So what is our plane that we are moving on? So let's say our character is standing on a slope. And if I click WSAD, my intent is to go in maybe 4 directions, so forward, backward, left, and right. But we can constrain it to plane and actually shift it, so our direction is like this. So this kind of our intended movement. Because we are taking information about the floor, where is the floor normal, so it would be something like this. We hit the floor normal is like this, and we do some calculation like that. So then we compute some velocity, constraint stuff, and at the end we take all of this, and the whole points of all of these calculations is to get this proposed move. So what move we want to make. So now that we have this information, next thing that is evaluated is, so we basically pass all the data here, and then we go to on simulation tick. And here is where the actual calculations of collisions, traces, stuff like that is figured out. But before we go here, let me go back to the agent pawn because we didn't cover everything. So in here, we also have the produce input. And for this, you need to have mover input producer interface. And this is important so you can get information about your inputs. Now, honestly, because we have this function directly in our agent pawn, we could just pass it directly here. But the idea is to use that input producer to get the information, so fill it up with information. If I do break, we have these input commands. And if I break it in here, we have input collection. So the same as we had like sync state collection, we have the input collection, and in here we can have like collection of data about inputs, and then we can pass that and do stuff with that. But since we are doing this stuff, we are using the interface to do stuff in the agent pawn because we need functions that is not read-only to do all of this stuff. We could technically just pass stuff in here. So when I press WSAD, I do some inputs, and instead of filling up these default inputs, and then later with these default inputs, I think I pass it into the collection and then pull from the collection, stuff like that. I do it in here. So this produce inputs function takes my inputs and then puts it in a collection, and then we pass the collection, and then that collection goes in here, and then we break it, and then we get the info, stuff like that. Honestly, because I'm doing it in here, I could skip this step, but I tried to do how developers intended it. And because this function for on generate move should have been in the movement mode, yeah, it makes sense why we have that collection. I'm not really the biggest fan of that collection type where you have a container with structs and you try to match it inside, stuff like that. It seems a little risky, I don't know, because then you have to have this brand to check if you even passed it, and then you have all this list. It seems like it would be a bit hard to debug, but maybe not. Maybe it's fine. But yeah, so after we do that, we process the input, we pass it to generate move does its thing, we get the proposed move. We can then go on simulation tick. And on simulation tick, let's break this down. Here we get a few things. Updated component and updated primitive is usually your capsule. So maybe later you can have a distinction. Primitive, I think, is just the visual stuff. Let me actually see. The sync might be moved by simulation. Okay, this is movement and this is the collision. So you can separate movement and collision. But it's actually being offset in the world and what we are testing the collision against. Then you have your mover component, which is basically this. Then you have your start state. Let's break this down. So your input commands, your sync state, and auxiliary states. Auxiliary state, I'm not sure what it is. Let me, yeah, I cannot break it down, never mind. But I think it's something about how you package the data or something like that. I'm not even sure. Like later after you finish up stuff, there's like some optional stuff that you don't even have to touch. I'm assuming like 99% of the time. So yeah, I haven't even went into that. So I left it alone. Timestamp that we checked out, and then proposed move. And we have a bunch of this stuff that we passed from the other guy, from the on generate move. So in here, what we have is a few things. So there is a bunch of stuff in here. Honestly, I'm not a big fan of how granular it is. I tried to basically copy paste how they did it in C++ in Blueprints, and there is some hacky stuff that I had to do. Blueprints were not able to do all of the stuff, but I didn't even do everything. So there is like initial overlap that I kind of skip, but I think I did like 95% of the things from C++. But yeah, it would be nice if we could kind of combine this stuff. It feels like it's so granular, like this could be like one function, maybe one function, instead of doing all of this stuff. But for now, it's like this. And just for Blueprints, because Blueprints do not like to have a lot of small functions, because then you create a lot of overhead and it becomes even less performant than it already is. You're going to lose a lot of performance doing like these granular small functions. But yeah, for now, we're doing it like this. So first we gather data, then we go here, we check if we have target location. So this is basically if you want to teleport the character, you just want the character to be in a place, in another place. You can do this instantly here, and we can just do some calculations. And we have return here, just return stuff. We just quickly teleport the character. This is kind of like the easy path. But for the movement, we don't even do this. We kind of skipped it because we want a character to slowly move. And there is usually like things, ground and stuff like that you need to take the calculation. Let's see this, attempt to jump. So here you attempt to jump and I think you do something else, I forgot exactly. Attempt to teleport or jump, yeah. So there is some stuff about orientation here that you do. And after we do that, we go here. And here is a big one. So first we try to find floor. And you can see here we have the wrap functions. And wrap functions is just blueprint wrapper that I created in C++ that just expose. There is few functions that for some reason are not exposed in blueprints. So I had to expose them myself. So if I open up C++, I just created the few functions that are just exposed. I didn't do anything crazy. I basically called their util functions and just wrapped them around so they are exposed in blueprints. So there is few functions like that. So that's kind of the hacky thing that I had to do and be creative in few places, but yeah. So then check if you can move full amount. So this kind of, we want to just quickly move the character instead of calculating if you're going on a ramp or if there's like a small rock that you just want to go over and not get character stuck on like small random 2 pixel things. Then in here we have some overlap stuff. So if we are overlapping or something, we can do stuff there. If we are not overlapping, we go in here and we check if we are blocked by something. If we are, we do some calculations. So we first try to move in the ramp. So that basically means if you're like going like this, how are we going to go up this ramp basically? Try to step up onto the object. So basically we're checking if, let's say this is our floor and we have like a small rock or something. We don't want the character to just get randomly stuck in games. That gets annoying. So we just make the character go over smoothly, like there is no rock at all there. Try to move with remaining time if the step up fails. This basically means that I think, so this kind of speculation, I didn't go too deep into it, but let's say we have a character and let's say we have a small rock and for some reason there is like another object here. I'm assuming if the character wants to teleport like in here or move in this stick like this, since we're gonna get blocked by stuff and the can step up to this rock is gonna fail, I think then we have some time remaining and we just try to move as close as possible or even move like this. I'm not sure exactly where you would move, but I think it's something like that it calculates. Then if you can see these sequences, I'm using them to just separate stuff so we don't have like false. Every time you see the sequence, imagine like on the false we have like few things executing. So basically here we want to execute this and whatever happens here, if we are blocked, we are not blocked, we just want to do some stuff here. And after that we go all the way here. We check if you're walking on the floor or falling. So this is if you want to go to another mode. So let's say we are falling and there is actually no floor below us. We don't want to move and we want to go to another movement mode. So we do it in there. And after all of this, if it falls that we need to do any movement, so if you don't have any input intent, stuff like that, we go in here and do some try find floor. So we just check if you're on the floor. And after that, we have this big third thing, which is basically we try to gather stuff. So we capture all of the data that we collected above, and then we just return the final output state. So if we go in here, try to make it, we can see what we have. So we have the sync state, auxiliary state, and then movement state, movement end state. I'm not sure if I can even break this. Oh, I can. So I can check if there is like a next mode, meaning if we want to go to like falling mode or something like that, we can do it here. And also if there is like a remaining milliseconds, so maybe, again, a bit of speculation, but if I understood it correctly, let's say the character is here and the next step of the character would be here. Maybe the actual movement is, so this would be like the full movement. And if we move just halfway, there is like a remaining time that now we need to be in the fall. So then from this, we switch to another state and say, you still have 0.5 or 50% of the move left, calculate it in your new movement state instead of this one. So that's that. And then you have sync state where you have, if you have multiple movement modes at the same time. I'm not sure exactly how that works, but it would work. And then sync states. So we collect the data, we add the data into the collection about our final state, the calculations that we basically did. So that's about it. Most of the things work, maybe not even most, maybe like 50% of things. Like a lot of the things work, but there is few things that do not work. So first, for example, if I move in any direction and stop, character automatically rotates on the x-axis. There is stuff with collision that kind of looks weird. So how he jumps, or like if I move like this, my collision is now up, the character is down. So stuff like that. If I start falling, he goes a bit to the right, which is kind of weird. And that's if I'm holding any input. So there is like random stuff that is happening. So not many things are working great. but in general it is working, so there is few things that need to be fixed here. In here I basically wrote down a few things that I caught that are not working. So first, our speed was really slow when I started playing. So right now I have just a multiplier, I think somewhere in here, I forgot exactly where. Oh, it's in here, time is 8. So that's not working properly. There is character tilting, some force when you're falling, stuff like that. So I wrote stuff down. So I'm gonna release this on GitHub so people can check it out and contribute if they want. Here's like few issues that could be fixed to make this properly work in Blueprints. Another thing, when I was testing stuff out, fixing some other bugs, I think what the biggest issue is that this start state is not working, meaning that whenever I checked it, it's always, everything's always zeros, it's never updated. So I think we are not passing data from tick to tick, so we are kind of doing a new thing every time. So I'm assuming like the movement speed is not accumulating, the rotation is not being set, stuff like that, so we are always resetting. So I think that's one of the things. So I'm not sure if it's the start state is not being called properly, it's not adding stuff in the collection properly, or maybe I'm not passing stuff properly in here. I think this is one of the more sketchy functions I did. But something is not working somewhere properly, so we have that issue. I think it's something with the start sync state. And I think if that gets fixed, like half of the issues will go away. So yeah, that's about it. If you want to check out the project, you can check it out on GitHub. And a little bit of shameless plugging. If you want to support me, I opened up a profile on the buymeacoffee.com, so you can tip me there. I also gonna post occasionally there with some updates. I have one update for this mover where I go in general about my thoughts about it and some things that I already covered in the video. And also, if you enjoyed the video, like it, subscribe. If I have any more updates about this, I'm gonna create another video, let you know.